Guys, back with part 2 of the kind of C data structures tutorials, or really just kind of talks. So in this one, we've kind of moved on from linked list to the next step up in stacks. So they kind of comes in pairs. When you learn about stacks, you kind of learn about queues at the same time. But I'm going to start off with one video about stacks, and then do queues next. Maybe binary trees, I don't know. Depends on kind of what I'm feeling, because I feel like binary trees kind of have a lot to do with stacks and linked list, and they're really good to talk about. They're really important. Well, moving on to what we want to talk about today, which is stacks. And so the point of a stack is, you can imagine as kind of what it sounds. You know, if I have a pile of letters, right, I'm going to take off the top letter and read it, right? There's no point in me taking off the very bottom and one out of the middle, okay? So you can think of it as a group of data that every time you want to access it, you grab the first guy, or the guy on top of the stack, right? And, you know, if I, sometimes I do this where I'll check the mail, you know, every day, but I won't open any of the mail. I'll just kind of let the bills pile up or whatever, and I'll create a stack of them. But when I come back and I start opening the guys off the top, they're the most recent elements, the most recent letters that I've put there, okay? So you may wonder, like, well, what about that really old data? Like, you know, it came in a while ago. Don't you want to deal with it when it comes in then? Well, there are certain, and that's what queues are for, really. But but stacks are used, for instance, like when I'm in robotics and I'm building a flight controller for a quadcopter, and the quadcopter, you know, it's piling up data in the back while it's doing some maybe mapping with 3D kind of, what's the word I'm looking for? Kind of, man, GPS. There we go. GPS, that's the word I'm looking for. So when you do GPS, and that takes a bit to do some trajectory planning. And when he comes back to look at his accelerometer, because he may be tipping over and whatnot, you know, maybe he's had 10 readings since then. But he's going to look at the most recent reading, because that's obviously something he has to deal with now. Like maybe 5 seconds ago he was tipping a little bit, but it doesn't matter. He may have stopped by then. He's more confident on what he's doing now based off the most recent reading. I still use the later readings, and it's important for me to get them because I use things called Kaufman filters so that they can better predict what their current states are, and that requires the more readings the better. But when he's first going to make his initial adjustments before he's decided on that filter and everything, he's going to look at the most recent guys, and that's who's on top of the stack, right? They're really similar to linked list, and I'll show you some little tips that make them a little bit more adaptable. Okay, so we have our struct right here. We're going to use the example of books again. This time they have a title and a price, and they have a pointer to the next book. And in this case, the next book is the previous guy that was added before him, because every time we add someone to the stack, they're on top, right? So his next is really the guy behind him in the list. So it's a little interesting to think about that. And we have the stack right here as a struct. Really easy. All it has is a pointer to the top. That's all we need. We only need to know where the top of the stack is. Okay. As a quick side note, it's the exact opposite for a queue. A queue, you just need to know where the front is because people go in behind them. But we won't worry about. These are some initial declarations, some implicit for the functions we're going to use. Just a couple functions. Push and pop are the two words you usually see when you use stacks and queues. Pushing just means putting something on top of it. I'm just pushing something right to the top, and pop, I'm just popping it right off, right? And so I just have some basic things. Checking if it's empty, because if I try to remove something from an empty list, that's a no-go. We can tell if it's empty. I'll show you how I'll do that in a sec. This function just basically initializes it by just setting the top pointer to null when you first make the stack, because there's nothing in there. And that's basically how I do it, is I say it's null, and if the top is null, it's an empty list. Display stack just displays the entire stack in order. So basically I'm just going to run through it real fast. We're going to run the main in a second, but I just initialize the stack. Then I just put 3 books on top of it. Harry Potter, $15. Data Structures in C, $25. And AI, A Modern Approach, good book, $65. And then I display it. But let's look at the functions first before I run that. So init stack, pretty easy. I just make a new stack object. I just set the top pointer to null, and I return it. Pretty straightforward. Empty, well, I just return the result of this expression. C doesn't have booleans, remember, so I got to return an int there, and then 0 for false, 1 for true. So S to the top equals null. If that's true, it's empty. Otherwise, if it returns false, it's not empty. So push. So I make a new book. I just allocate the memory because it's a book pointer, right? When I'm popping somebody off or pushing somebody onto it, I need to edit the values inside of the books because they point to the next guy in the stack, the guy below them in the stack, right? And so on and so on. So in order for me to edit that, I need to pass in, same with the stack, for me to edit who the stack is pointing at the top, I need to pass in the pointers to them because I'm editing something. I don't want a copy passed in, I want a pointer. So I know where their address is and I can manipulate the stuff in their address, not a copy. Okay, so I'm going to just put in a pointer to my stack, and then a title and a price, just string and integer. Make a new book. I'm going to allocate the size, the memory. I'm going to memory allocate the size of what a normal book would be to this book pointer. And then I'm going to just set the title equal to the title I put in and the price. Pretty straightforward, just making one. And right here I just have a quick check. Is it empty? If it's empty, then the new book's next guy is going to be null. So next is the guy below him, right? So if it's empty, there's no one below him, right? Because he's at the bottom. I'm putting him in the stack, and he's at the very bottom. So as soon as we pop him off, and top becomes, whoever he was pointing at, top will become null, and then we'll know we're empty again. So you'll see an example of that in a second. Otherwise, the new book's next guy is the current top guy, because we're putting him on top, the new guy. So the guy below him is the next book in line. Okay, popping it off. If it's empty, we just exit because we're like, hey, there's no books left in stock. I'm imagining like this is a bookstore, and as we get a book, we put it on the shelf. As new books come in, we kind of replace them, and those little books kind of go into the back of the store, right? The books that didn't sell go towards the back because people don't want them. Your fancy books that everyone's in for, like when the new Harry Potter comes out, for example, boom, it's going right out front. The new James Patterson, I really don't like him that much. We asked, my mom loves him. She's got tons of books. To pop it off, if it's not empty though, we'll continue down here. And so we'll make a book pointer object called book sold. I'm saying popping it off is basically like selling the book. So that's equal to the guy on top, right? It's our stack's top guy. And then the new top guy is equal to the top that we just pops off next guy, right? So we just pop them off, and then we go, wait, who is the next guy? And we look at his next. Throw him out and say he's the new top guy. Boom. Okay? And then I just print out sold, the title for whatever price he is. Book sold title, book sold price. And then if you want, I also return the book sold in case you want to do anything with it popped off. This doesn't need to be there per se. I could do this as a void, but sometimes it's nice to have results coming out of your functions to deal with those. And then final function, display stack. I just print what's left in stock. I just make a book pointer that points at the top, and then I just cycle through the list. So while the current book is not null, just print out the title and the price, and then the current book is equal to the current book.next, whoever's below him, whoever's next in the stack, right? And then just a new line at the bottom. Okay, so pretty straightforward. So on our main function, we just initialize the stack right here. I just put 3 books on it, and then I display it. Let's run that. Takes a bit. Boom, what's left in stock? AI Modern Approach, Data Structures in Z, Harry Potter. And you notice I put in AI Modern Approach last, but it's on top because that's how the stack works. We're piling them on top, right? And you notice the first guy I put in Harry Potter, he's on bottom. Okay? Now let's uncomment some stuff. Let's start selling some things. So if you notice, for pop, I just need to put in the pointer to my stack. I don't need to put in what index or anything because it's the stack. It'll take the guy off top. So like, with the sit robot, right? He'll look at the first, I just need to tell him where the array is, and he'll look at the most recent data entry. Okay? I'm just going to display the stack after that. Okay, let's run it again. All right, and then we sold AI Modern Approach for $65, sold Data Structures in C for $25. What's left in stock? Harry Potter. That's it. So it's the guy that was on bottom. Okay? And I'm going to sell Harry Potter, and then I'm going to try and pop it again. And we'll notice now that the top was null after we pop off Harry Potter, it's going to give us an error when we run it. No books left in stock. Process returned 1. So it exited with the code 1, which I put in is a case when it's empty. Right? So that's kind of a really quick rundown on stacks. But if we look at another thing, say we want our stack or our books, right? Say we want them to now have barcode numbers. We want them to have maybe like genre, and a lot of these things. If I were to add those in, I need to make this function bigger. I need to change popping. I need to change a lot of things, especially in the linked list example where like when we're searching for values and such. It makes it a lot harder because I have to change the whole code up. I have to change the memory allocated. I have to come in here and change this. When I push a book, I have to change what I put in here. I have to change a lot of the code. But if I come into here, there's another example of a linked list where you make one extra struct called stack data. And it's up to us what we put here. Spell commas wrong. Okay, so title, price, same thing as before, but now our book just points to a struct data object. Okay, and now it's the same, except the only thing I have to change now is when I push, I just have to put in one object or one struct, which is just the stack data. Okay. Main's a little bit longer because I have to just do stack data, s.title equals that, s.price equals that, and such. But as you can see, the functions are pretty much the same, except when you get down to printing things out, right around here, I go book sold, and then I go to its data element, and then I go title and price, okay? Stuff like that. So what does this allow us to do? Well, I can come up here and I can say, instead, I'm going to add in a int, and first off, just to make sure that this is running correctly. Yeah, okay, great. And you notice that we can do all the same things we did before, like popping off. I just, instead of all of my data stored within the book, I have it stored within inside a struct. And I'll show you the advantage of that in a minute. I'm just going to make sure everything's working like it's supposed to. Okay, yeah. So it's doing exactly what it did in the last run code, just with stack data this time. Okay. So say I want to come in here and I want to throw in int barcode, and then I want to throw in genre, like I said. Okay, genre. I hope that's how you spell genre. I think so, but okay. So I just added 2 new data types to struct data, and it completely worked. It's still completely working. I just added extra stuff to our things. I didn't have to change anything. If I want to, and so any current books that are already in there don't have, they have these built into them, so I can make a function to, take inputs and put those in, or modify existing books. But I can freely experiment by throwing in data types, and the only thing I have to really change is I just have to come down here, and I just gotta go s.barcode is equal to 1, 2, 3, 4, 5. Title, price, barcode. I just gotta make minor adjustments. Current book, data dot was barcode. Yep. All right. And you'll see the barcode for these guys don't print anything. It's totally fine. I never ever had to declare barcodes for them, but it still works. It's totally fine. Except for this guy, his barcode didn't work out. Push bargain, yes. Harry Potter's bar. Oh yeah, I never put the %d in there. Let me do that. Oops. Oh yeah, though I didn't change the barcode for any of these guys. Okay, yeah, so I just edited something a little bit. As you can see, there's no more, I don't edit the barcode out here. I do something fancy in here where I say, if it's the first book, give it a barcode of 1, 2, 3, 4, 5. And any future book, just give it a barcode of the top guy's barcode plus 1. Now to implement barcode, it only took me, what, like 3 lines of code? I just had to change, 1 in here, one thing in the print statement, and then I threw in, I don't know, 2 lines in here, and that's fancy. And so instead of having like a bunch of different variables, global variables to store like the current top guy's barcode, or to store a bunch of other things, I can store it inside of this data struct and call upon it whenever. And if I make this into a library and somebody else needs to do a bit of, they want to organize their books differently, or maybe they sort their books by, Boolean values, I don't know, something like that. They can really easily and really quickly redefine their code by just throwing in variables inside of stack data. So it makes it really adaptable to use it that way. So that's a little bit on stacks and what they're used for. And if we actually run it right now, we'll see that we get 1, 2, 3, 4, 5 for the guy on the bottom, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 6 for the guy on top, 1, 2, 3, 4, 7 for the guy even above that. So you can see that stacks are pretty useful if you want to work with data that you always want to deal with the most recent guy first. The guys that kind of go toward the bottom are stale data, as I like to call them, stuff that we don't necessarily care about. And so I think that's all I need to really cover on stacks. Next time we'll talk about queues. All right, see you then.